Hey Heather, so I want you to pause the video, I want you to do the 4 questions, and once you've done that, unpause it. I'm just about to go over the answers. So, first one, what is meant by an essential oil? An essential oil, you need to know, is non-polar, yeah, and that makes sense obviously because it's the oil part. It's a non-polar hydrophobic, yeah, non-polar hydrophobic, non-polar hydrophobic volatile aroma compound composed from plants. Okay, very important you know that. Non-polar hydrophobic volatile, yeah, evaporates easily, aroma compound composed from plants. What do essential oils mainly consist of? Well, that is you should know this, terpenes and terpenoids. Okay, remember a terpenoid is an oxidized oxygen containing terpene. Okay, give the systematic name for an isoprene unit and draw it. Okay, we'll draw it first. Now, obviously you can start with the sort of the dog with no front legs. Yeah, that's a skeletal structure, but ideally you want to be drawing it out normally, okay, like so. Yeah, and again we've got a methyl, let me just highlight that, we've got a methyl group on carbon 2 and double bonds between 1 and 2 and 3 and 4, so this is 2 methyl buta 1 3 di, because there's 2 carbon to carbon double bonds, diene. Okay, you need to know the structure. 2 methyl buta 1 3 diene. Question 4a, circle an isoprene unit on the structure below. Now I'm just going to highlight them because it will be easier. Remember, an isoprene unit has 5 carbons, 1 2 3 4 5, so you're after 5, so 1 2 3 4 5. Okay, so you could have circled that, or you could have circled the other 5 carbons like that. Okay, so either one, whether you circled the yellow one or the orange one, that is your isoprene unit. How many isoprene units make up this molecule? Well, I've pretty much done it for you. 2. Okay, nice and easy. Remember, just count the carbons, divide by 5, that's how many isoprene units you have. Again, a very common question that comes up in exam papers, how many moles of hydrogen could be added to fully saturate this molecule? Now, remember what we said in the life lesson, that one molecule, yeah, is H2. Yeah, because hydrogen is diatomic. Now, we have 1, 2, 3 carbon to carbon double bonds, so our answer will be 3 moles of hydrogen. Yeah, because at each carbon to carbon double bond you'll get a H added, so 3 moles of hydrogen. Right. So what we're going to do now, I want you to put the heading Fragrances and Skincare Lesson 2. This will be the final lesson on this. So obviously last lesson we looked at fragrances, essential oils, terpenes, so on and so on. We're going to start focusing on the skincare aspect of that. Okay, now it's going to start with ultraviolet light. Okay, now I'm going to be writing ultraviolet quite a lot, so I'm going to sort of shorten that to UV. Okay, ultraviolet UV light. Yeah? So, let's make a wee note on what ultraviolet light is. So, UV light is a high energy form of light present, and you probably already know this already, but it's present in sunlight. Okay? Present in sunlight. So, I'm going to start talking about the energy. So the energy present in UV light. Yeah, and remember what we said, it's high energy, okay? So the energy present in light can be sufficient enough to break bonds within molecules. Okay? So because the UV light has a lot of energy, that's sufficient enough to break bonds within molecules, and what happens, they break it within molecules to form free radicals. Okay, now this is a new word, free radicals. So I'm going to highlight it. Free radicals. Now, this is a definition you need to know. You need to know what a free radical is. Okay, so it's one of these that simply you need to memorize. So a free radical free radicals are atoms or molecules that are highly reactive. Okay, and why are they highly reactive? They're highly reactive due to the presence of an unpaired electron. Okay, so it's very important that you know, okay, so I'm going to highlight this in orange, very important that you know what a free radical is. Yeah, highly reactive atom or molecule due to the presence of an unpaired electron. Okay, so important that you know that. Now, I'm going to show you exactly how it's formed. Let's just say we take hydrogen, yeah, and we add UV light. Okay, I'm going to highlight that. We add UV light, and what happens is this bond between the hydrogen breaks, and we are left with two free radicals. Okay, so this is what we mean by a free radical. And this wee dot here that I've done, this just tells us we've got an unpaired electron. Okay, that's that wee dot. Now it's very important that we only get free radicals if we're using UV light. Yeah, if we took hydrogen H2 and we supplied heat energy to it, we wouldn't get free radicals. We only get free radicals when we're sort of reacting it with UV light. Okay, that's important. So let's carry on our note. This process, okay, the whole creating free radicals and so on, this process is the reason for sunburn. Okay, and obviously if it's a long run, if you're exposed to UV light for long periods, it can lead to cancer. Okay, so and cancer in the long run. Okay, and also not only does it cause sunburn and cancer, it accelerates aging of the skin. Okay, and accelerates aging of the Yeah, it makes the skin look almost leather-like. Now, obviously there are ways to combat this, yeah, and the most common one is putting on sunblock. Now, I would normally call it sun cream, but the SKA call it sunblock, so that's what I'm going to start calling it as. So sunblock products helps as it prevents UV light reaching the skin. Okay, and how does it do that? Well, it acts as a barrier. Okay, it prevents UV light reaching the skin as it acts as a barrier, and it reflects the UV light. Okay, that's why we put sun cream or sunblock on, and you need to know that. Okay, you can get asked about this, so please make sure you know this. Yeah, sunblock is acting as a barrier and it's reflecting the UV light. Okay, it's all about UV light. Right, so the next one we're going to look at the chemistry of this, what's actually going on. So this is known as free radical reactions. Okay, free radical reactions, or chain reactions would probably be a better term for it, but we'll write that just now. So, so free radical chain reactions, and you'll see why it's a chain reaction. Okay, free radical chain reactions start when UV light, and remember it's always UV light, okay, when UV light breaks a molecule into free radicals, okay, and we should know what a free radical is. Now, it's a highly reactive atom or molecule due to the presence of an unpaired electron, okay, so highly reactive due to the unpaired electron, and we show that unpaired electron with the wee dot, yeah. Now, this whole free radical chain reaction, it has 3 steps in it, okay, it includes the following steps, okay, and you need to know each step. Okay, the first step is initiation. Okay, the second step is known as propagation, and the final step is known as termination. Okay, and you need to be able to recognise them. Yeah, initiation, propagation, and termination. Okay, so we're going to go through each step. I'm going to give you a sort of reaction, and we'll go through it each step, and then we'll do another reaction just so that you're understanding it. Okay, let me just move this up. So let's do an example. Example 1. Okay, so hydrogen reacts explosively with chlorine in the presence of UV, ultraviolet light. Okay, it's always with UV light. If we did this experiment with just hydrogen and chlorine and we added heat energy to it, we wouldn't get this explosive nature of it. Okay, it's because of the UV light. Okay, so the reaction you should know, yeah, both hydrogen and chlorine are diatomic, so it's H2 plus Cl2, and that goes to HCl, and if we wanted to balance it, we just put a wee 2 there. Okay, so 2 HCl molecules. Now, we're going to look at what happens here. So, we're going to start with the initiation part. Okay, we are initiating the reaction, and what we mean by initiation in terms of sort of free radical reactions is free radicals are formed. Okay, and you need to be able to recognise these free reactions. So the way to recognise an initiation reaction is that free radicals will be formed. Okay, now just before I forget, I'm going to give you a wee side note. Okay, so we're going to look at these two molecules here. We need to know what one is going to form the free radicals first. Okay, now you should already know this because we've done it before, but the molecule with the lowest bond enthalpy, yeah, and you can get the bond enthalpy from the data book. See page 10 of the data book. Okay, and whatever molecule has the lowest bond enthalpy, that one breaks first. Okay, it breaks first. So, I just so happen to have a data book here. So, between hydrogen and chlorine, let's look at our bond enthalpy. Yeah, page 10. Hydrogen, HH, is 436. Chlorine is 243. Okay, so because the chlorine has the lowest bond enthalpy, that's the one that breaks first. Okay, so we're going to focus on that. So what happens is we've got Cl, Cl, and obviously it's the UV light. Yeah, it's the UV light that's initiating this. That forms, that breaks that bond, and what we're left with is 2 chlorine free radicals. Yeah, so this is initiation. We're starting with a neutral molecule, yeah, that breaks using UV light, and we're getting free radicals forming. Okay, that's how you recognise it. So what we're going to do, we're just going to focus on one of these free radicals, so I'll highlight that. We'll come back to it. Now the next step is known as propagation. Propagation. Okay? And the way we identify a propagation reaction, well, equation, is one free radical makes another free radical. Okay, so one free radical makes another free radical. And it's this part here, it's this propagation step that we know as this chain reaction. Okay, so basically what's happening here is one free radical makes another free radical, then that free radical makes another free radical, and then that makes another free radical, and it goes on and on and on and on, and it sort of starts a chain reaction. Okay, so let's focus on this chlorine. Okay, so we've initiated the reaction with UV light and we've created a chlorine free radical. Now, what happens? This chlorine free radical, okay, and just to identify it's this one that we're talking about, yeah, it's the one that was made. This chlorine free radical can then react, because they're highly reactive, it can then react with the H, yeah, the H2, the one up here. Okay, it can react with the hydrogen molecule, and what happens, that chlorine reacts with a hydrogen to form HCl, yeah, so those two join, that bond breaks, and what we're left with is a hydrogen free radical. And I'm going to actually highlight that orange. Okay, so we know this is a propagation, a chain reaction step, because a free radical has made another free radical. Okay, that's how we know it's propagation. In this reaction, we're starting with a neutral molecule, we're forming free radicals. Propagation, a free radical is making another free radical. Now the cool part, what happens now is this H free radical, yeah, that we've made can then react with another chlorine molecule, yeah, ClCl, and again that H reacts with that chlorine to form HCl, yeah, and because that bond breaks, we're left with a Cl free radical, yeah, so a free radical's made another free radical, and then that chlorine, yeah, can then react with another hydrogen molecule to form that in a H free radical. Then that H free radical can react with that chlorine, and it goes on and on and on and on, and it's a chain reaction, okay? And that chain reaction will continue. It will keep going on and on and on until either we run out of molecules, or what happens is we go to the termination step, okay? Now, this should hopefully be obvious to what's happening at the termination step, but essentially the free radicals are becoming terminated, yeah? So, to recognise a termination step is when free radicals react together, they react together to form neutral molecules. Okay, so no longer is a free radical creating another free radical. Yeah, the free radicals come together and they create a neutral molecule. Now, there's many ways this can happen. Okay, we can have a hydrogen free radical reacting with another hydrogen free radical, and that would give us a hydrogen molecule. So the chain reaction has stopped. Yeah, we could have a hydrogen free radical, yeah, or we could have a hydrogen free radical reacting with a chlorine free radical, and that would give us HCl, and again the chain reaction has stopped, okay? Or we can have a chlorine free radical reacting with a chlorine free radical, and again it's stopped. Okay, so that's our free reactions. You need to know the steps. Okay, initiation, we're forming free radicals. Propagation, a free radical is creating another free radical. Yeah, and then finally termination is when free radicals come together to form neutral molecules. Okay, you need to be able to recognise all these reactions, and it starts with UV light breaking the bond with the lowest bond enthalpy. Okay. Right, so I'm going to do one more example. So we'll call this example 2, obviously. And we're going to look at this reaction here. CH4, so methane, we're reacting it with bromine, so Br2, in the presence of UV light, obviously. And we are going to create CH3Br and HBr. Okay? Now, just to sort of show you what's happening here, I'll draw it out. So if I draw out a methane molecule, yeah, draw out the bromine, just so you can see it clearly. So essentially what's happening here is that a Br is substituting with a H from the methane molecule. Okay, now if we look at these two, yeah, we've only got two types of bonds. We have a CH bond and we've got a Br bond. Okay, now if we look at our data book, page 10, the Br bond has got a bond enthalpy of 194, but the CH has got a bond enthalpy of 412. Okay, so because the Br bond has a lower bond enthalpy, that's the one that breaks first. Okay, because it's easier to break first. So Br has lowest bond enthalpy, therefore breaks first. Okay, so let's go for our steps again. Initiation. What's happening here is free radicals are made. Okay, free radicals are made. So because the Br bond is breaking first, let's show that. So Br, and again remember it's not heat energy, it's UV light, and that is going to break up that bond and form two bromine free radicals like that. Okay, so again I'm going to highlight just one of these bromine free radicals. So that bromine free radical that I've highlighted, that can then go through a propagation step. And remember what we mean by propagation. That is when a free radical makes another free radical. Yeah? Oh, I'll move over. So a free radical is making another free radical. So that Br that we created in the initiation step, what that can do, that can react with the CH4. Okay? And then what happens, it reacts, that Br reacts with one of the H's of the CH4 to give us HBr. And then what we're going to be left with is CH3 free radical. Yeah, because remember, free radicals don't have to be just atoms, they can be molecules as well. Okay, so Br is reacting with one of the H's to form HBr, and we're left with CH3 free radical. Okay, and I'm going to highlight that orange. Okay, so it's propagation because of free radicals created another free radical. Then that CH3 free radical, yeah, that can react with a Br2 molecule, okay, and it creates CH3Br, okay, so it takes one of the Brs, and then we're left with a Br free radical, yeah, and then again it's propagation because a free radical's created a free radical, and that Br can then react with CH4 and so on and so on. It can go on and on and on. It's a chain reaction. Okay, now that keeps on happening until we run out of molecules or the termination step happens. Okay, and remember what I said about termination. That's when free radicals react together to form a neutral molecule. Okay, a neutral molecule. Now this can happen again multiple ways. You can get a Br free radical reacting with a Br free radical to give us a bromine molecule. Okay, you can have a CH3 free radical reacting with a bromine free radical to give us CH3Br, or we could have two CH3 free radicals to give us C2H6, which is ethane. okay? And that's it. Okay, that's how a sort of free radical chain reaction step happens. Now, we know, obviously I'm just telling you these are the steps, but there is sort of evidence to this, okay? So this mechanism, we know there's an initiation, propagation and termination step because this mechanism, yeah, is backed up as once the reaction is initiated, sorry, helps if I can spell, is initiated with UV light, it can continue in the dark. Okay, so what we mean by that is the minute we've broke that bond, yeah, we've added the UV light, we've created our free radicals, the second we've created our free radicals, we can put the reaction in the dark. In this propagation step, it still takes place because it's a chain reaction. Okay, so that's how we know we've got these 3 steps. Right, now, the very last thing I want to talk about is something called free radical scavengers. Okay, free radical scavengers. Now you need to know the definitions of this. Now you should know the definition of what a free radical is. Yeah, highly reactive unpaired atom or molecule containing a unpaired electron. You need to know the definition of a free radical. Okay, now with free radicals, many cosmetics, okay, and probably the most common one, including after sun. Okay, I don't know if you've heard of after sun, you probably should have. After sun is basically once you've been out in the sun, you put it on after you've been out in the sun. Yeah, so many cosmetics contain free radical scavengers. Okay, and you put this on after you've been out in the sun because it helps protect your skin. Okay, and I'll talk about why it helps protect your skin. But basically, this is the definition. Okay, you need to know this. So, free radical scavengers react with free radicals to form stable molecules and prevent, okay, this is a big one, and prevent further chain reactions. Okay, so what happens, this is why we put it on after we've been out in the sun. Okay, so if obviously we've not got sunblock on or we've not got enough sunblock on, obviously we'll have free radicals, there'll be chain reactions happening in our skin. So we put after sun on, and the free radicals that are within after sun, they react with any free radicals and they form stable molecules. Okay, and it prevents further chain reactions happening, further damage to your skin. Okay, so this bit here, you need to know. Okay, you need to know a definition of a free radical, you need to know a definition of a free radical scavenger, and not mix them up. Okay, so last wee bit. Okay, so free radicals remove electrons. Okay, move electrons from skin cells. And what that does, okay, if the free radicals remove electrons from skin cells, they damage them. Okay, and damage them. So what happens is that this is what's happening from a chemistry point of view, the free radical scavengers, yeah, they provide electrons and replaces them as free radical scavengers are antioxidants. Okay, now antioxidants is a brand new word, but I'm not going to go into detail here. I just want you to see later, and that's in the whole chemistry of cooking. Okay, so don't worry about antioxidants just now. I'll explain what they are in chemistry of cooking. So this is what's happening. The free radicals are providing electrons, yeah, that the free radicals have removed. And because that's happening, it replaces them. That's why it's protecting your skin that way. Okay, so let's summarise what we've done. We have done quite a lot today. You need to know what UV light is, yeah? High energy form present in sunlight. UV light leads to the production of free radicals, yeah? You need to know what a free radical is. Atoms or molecules that are highly reactive due to the presence of an unpaired electron, and that's how we show an unpaired electron, that wee dot, okay? We can use sunblock because it helps as it prevents UV light from reaching the skin, as it acts as a barrier and it reflects the UV light. Okay, now the next part that we spoke about are the free reactions and a free radical chain reaction. Okay, so initiation, propagation, termination. You need to know how to recognise them. Initiation starts with UV light. It breaks up a molecule with the lowest bond enthalpy and it creates two free radicals. Okay, propagation is when a free radical creates another free radical. You need to be able to recognise that. And termination is when free radicals react together to form a stable neutral molecule. Yeah, you need to know that. Okay, and that one there obviously just backs up what I'm saying. And then finally, the last thing we spoke about was the whole free radical scavengers. Okay, they react with free radicals to form stable molecules and prevent further chain reactions. If we look further into the chemistry of it, they are providing electrons and replacing the electrons that the free radicals remove. That's how we repair the skin cell damage, essentially. Okay, so I'm going to put some questions up in Teams for you to attempt, and that'll be us. So thank you.